Okay, it's recording. It's kind of dark and misty. What am I going to talk about today? Is the Earth flat, round, globocentric, heliocentric? Just really talk about that. I mean, there are a lot of things that science talks about, but they never tell you the experiments to tell you that it's true. Whatever they're going to be talking about is true. Not even a down scale size, not scale size, but down size model. Some things we might not be able to feasible to do a scale size model, but first they haven't been able to tell us if the distance of the stars are actually accurate. Like, how do they know? Like, they tell you it's the archangel, not angel, arc-angle, or the arcsecond of this, and it's like, whoa, okay. I'm not a mathematician, so yeah, you do your cosines and your point A, point B, and these two make a arcsecond, which is a very, 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 very small angle. It's not even an angle. Well, it is an angle, but it's not a degree. It's less than a degree. It's so small it's basically less than 1 degree. That's how small these arc seconds and arc minutes and all that stuff is. And I'm like, but how do you know? Have you ever done that? I mean, and why? And everything is based upon the mathematics. It's mathematics that have not been really tested at a smaller level. So they'd be like, well, the Earth goes around the sun and it has a travel distance of this, and sure. But the problem is, if I put you in a pitch black 200-meter warehouse, right? Be a pretty big warehouse. Pitch black, and I randomly turn on a light bulb about the size of maybe a golf ball. Could you tell me the distance with your guess? And you have no other object to guess. You have to walk here, walk about 3 paces here, and be like, okay, and then make an angle. And that's what they're, and that would be a experiment they can do, and I don't think they have done that. Instead, they just make all these accusations of no real. They have math, and then they make some type of accusations and assumptions without testing the assumption that they make, and they plug it in and call it science. But what is the biggest problem with the heliocentric model? It's the stars and the planets of the night sky. Venus and Mercury should never, or maybe a week, if that, be in the night sky, but you see them all the time in the night sky. And it's not just at the crack of dawn. I have one out there midnight and be like, oh, look, there's Venus. And I was right. The number 2 problem is things like Mars, Jupiter, and all the planets beyond Earth that should be in our night sky, but only part of the year. Like 6 months out of the year, we should not see Mars, Jupiter, Saturn, Uranus, Neptune, and if you want to count Pluto, whatever. I'm not going to go too far on what's technically a planet and what's not. We should not be 6 months out of a year, because if Earth takes 6 months to get from summer to winter, and let's say we're at our summertime, and Jupiter is at our winter time, we should not see it if Jupiter moved, and that's if Jupiter doesn't move 6 months. well, 3 months, but it'd be kind of at our crack of dawn or crack of dusk. So there's a very narrow road that we should see it. And but as we're moving, Jupiter's also moving, so it may even take longer than 6 months. It may be only 9 months out of the year that we shouldn't see any of our solar outer planets, but we do. And then the same thing is true with like the constellation, like the Big Dipper and Orion's Belt. As we move from winter to summer or spring to fall, whatever, through the seasons, there should be constellations should not just change precision in the night sky, they should completely change altogether. There shouldn't be no Big Dipper in the spring and also in the fall. The Big Dipper should not exist in opposite seasons, but they do. This is a massive problem, really bad problem. And you can say gravity and black hole bends light, but they're bending light that much to be in our sky all year round doesn't fit. And I'm gonna admit, I don't know how gravity affects life, but you're saying it bends it all the way around the sun. I don't care how it bends it and puts it in our night sky where it should be, and then you're getting directions saying that this star is this far away. It doesn't make sense. So I'm going to admit it doesn't make sense, and no one has actually been like, hey, well, this is yes, we're taking a mirror image of the night sky and telling you the distance of a star based upon its light bend reflection. Yeah, that's what would have to happen. So that's the major problem with the heliocentric Earth. Now, the global center of Earth makes sense. You can say all the constellations and all that rotate around the planet. All the rotate. And they rotate in such a way, and it's basically a figure eight. This is the most common observation that we see with our eyes, that everything goes in a figure eight. But then that means things have to be a lot closer and a lot smaller, and stars can't be billions and trillions and quadrillion times bigger than Earth. Can't be. And then we have the flat Earth, and the flat Earth needs an electromagnetic force field thing where the firmament is somehow electromagnetic circuitry that goes on, or something to that effect. And that would be even harder to test at a downsized model, but at least we can make circuitries a model where circuitry works and stuff like that. And people have tested static electricity being caught in water and it looks just like a star at night. So really, now you have to prove whether the Earth is round or flat, because it's either going to be the globocentric Earth model that is right, or the flat Earth model that is right. The heliocentric model can't be right. So far, they haven't done anything to prove it's right. There's so much of a optical illusion out there that we're supposed to see something as billion years away, but on the opposite side of the sun, and we're still seeing it. That is too much of an optical illusion for me. Now, people be like, well, the curvature of the atmosphere. Well, hello, dummy. If you believe in a dome is round, and if the Earth is flat, the ground will be flat, the sky will be eventually curved. So you can't be looking at the sky and see if whether or not it's curved or not. You would then have to look down at the ground and see if the ground is curved, not the Earth. And the best way to actually do this is what I call shoot an azimuth. An azimuth is when you take a compass and you look at your compass and be like, oh, I'm facing 72 degrees. Well, that's a 72 degrees azimuth. And the best way to do this is fly from Chile to Australia. What you do is you take a map, you measure the distance between Chile to Australia, you see the coordination is roughly a 90 degree or 270 degree azimuth, depends on if you're going from Australia to Chile, it's 90. From Chile to Australia, it's about 270. I said about. I don't have a map in front of me, and I'm not doing it. And then you fly a plane, and you do the calculation. If the plane is flying 480 miles per hour, and the distance is X, and then Y should be how much time it takes to fly it. And that's what you do. Great. That's what it should be. And you test it about three times minimal so you can get an average. But if the flat Earth is right, then you might not hit Chile, you may hit another place. Or it may take twice as long to get to it. And that's how you would really test the flat Earth. And I'm just using the idea of shooting an azimuth, having a compass, and then you'd be like, how about magnetic north and grid north? And you would always have to add and subtract based upon the grid and magnetic north difference with your azimuth. And over that large distance, someone can be like, there's too much fallacy. But really, that's the only way to test it and to record it. And I don't know how to fly planes. I don't even have the money to buy a plane, but really, and that's about it. No, I'm going to say but the heliocentric model I'm completely against. I am leaning more towards the flat Earth because it helps fit in with the 6,000 year creation. Because that means the stars are a lot smaller if the stars are actually balls of plasma or fusion, and if they are angels, as some people have suggested. And yeah, they're a lot smaller and a lot more. They're a lot smaller and a lot closer. So yeah, I'm really. So yeah, I don't believe in the heliocentric model, but because in the middle of it sounds like hell is in the middle of the heliocentric model. And I just want some actual data to support the distance of a star. Like, hey, yes, that light bulb. We did our little light bulb test, and we were right 100% of the time without using lasers. With the guess of our angle with our own eyes and instruments, just like we do with this. My guess on that is they're going to see an increase of how off they are. Someone shines at 150 yards and they guess it to be 165 yards. And if they put it at 165 and they guess it to be 140, see, and that's what I believe would happen. The farther out they go, the harder it's going to be accurate. And it's a pitch black room and someone shines a light and the only person knows the distance is the person who turns on the light. So thank you very much for watching this. So this is the heliocentric versus global centric versus flat Earth. Part 1 out of X. There may be a part 2. Stay around for next time to find out. Bye. God bless. Shalom.